All right, so this video is on the limit definition of an integral. We're kind of talking about how we can break down and find the area under a curve by making a million bars, basically, a million little rectangles. So this example is on page 300, it's number 57, and we're trying to find the area under the curve for this function from here, 0 to 2. Now, for these, I would like to use A, like the beginning point of where we are, to B, the ending point of where we're going to be, just in case we need to reference them. So we want to set up an integral that looks something like this. It's the integral of base times height, really. And we're going to take the limit as the number of bars, and the number of bars goes to infinity. And with this problem, you'll notice that it's f of y, not f of x. So what you can do is you can just cheat and change the y to x, and it'll work pretty much fine like that. So instead of doing the problem like sideways, we'll be doing the problem the regular way, up and down. So let's go ahead and try it. We'll go back to these as we need to. So just change y to x. So I have f of x equals 4x in that case. So that shouldn't be too bad. F of x is equal to 4x, and the interval is from 0 to 2. And it's still x because we changed everything out. And then you want to get a basic drawing of that integral, that area. So let's check it out. Pretty much we just want to draw something that looks something like this. And we want our function to be 4x, so kind of steep, but we won't make it super steep, so we have enough space here. So 4x. So I believe this would be then maybe 8, comma 2, and then this would be perhaps 4, comma 2, or 1, 4, comma 1. So that's the drawing of your region. That's 1 and that's 2. And let me just move this 1 over so it looks a little bit more official. Whoops. Unfortunately, can't get it. So maybe somewhere around here would be better. A little bit better. Okay, so that's basically where we're at. We have a drawing. We want to find these bars. So I'm just going to draw a random bar in here inside of this. So I'm just going to draw a random bar in this area. Okay. So that's just a random bar. It's not really anything. But we know that that random bar is going to have a width of delta x. Delta x. So I'll use red because I've written your delta x in red. So this bar's width is delta x. And what you really want to do is you want to figure out how wide the bars are. So if we're going from 0 to 2, how wide is our whole region? It's 2 units, right? From 0 to 2. So we've been calling these, I think we called them A and B, right? So you might find a formula that says B minus A over N. If this is A and this is B, well, that means the region is B minus A, which in this case is 2. And we want to divide that by the number of bars, which is N. So I'm kind of jumping ahead to the delta x thing. Delta x will always be the width of the region divided by the number of the bars. So delta x is going to equal, the width of the region is 2, and we're going to have n bars. And we're going to make the number of bars goes to infinity later on, but for right now we're just going to have n bars. So that's delta x, and hopefully that is making sense so far. And now we need to take it to the next part, and this is where it gets a little bit tricky. So now what we need to do is we need to figure out c sub I. Now c sub I is just a nice way of saying the x value for finding the height of the bars. So c sub I is this x value for finding the height of the bars. If we look back, we see that we have this blue f of c sub I. We don't even want to find out f of c sub I. We just simply want to find out c sub I. And if we look at our drawing, c sub I is going to be this right here. We're using blue for c sub I, I believe. So c sub I is going to be this x value right here that we plug in. So that right there would be c sub I. But the reason that it's c sub I is because we're going to need to do that x value, we're going to need to do that like a million times to make all these bars. So we're going to have like infinite c sub i's. So we're going to need to use summation to make that happen. So let's try to figure out C sub I. So C sub I is going to be always, if you look at like the region that we're dealing with, right? And you say, okay, well, I'm starting here, this is A, and I'm ending here, this is B. I'm trying to get this area, this is a different problem. Well, C sub I will always be if you add delta x to your original and then plug in to your function, this right here will give you, this is f of C sub I, and this right here is C sub I. So what I mean to say is that C sub I is always going to equal your original place, which is A, I think we were doing that in green, plus delta x times I. Now why is delta x times I? Because we're going to be getting an infinite number of C sub i's. So we're gonna have like, I don't know, let's say if we said the width of the bars was 1/2 and we were starting from wherever, let's say A is 1 and B is, I don't know, let's say B is 7. Okay, and the width of the bars is 1/2. Then we know that our first bar is going to be at 1.5. So it's going to be that original number plus the width of the bar, which is 0.5. And we know our second bar, we're going to have to plug in at 1 plus 0.5 twice, right? So that's going to be where our second bar is. And then we're going to have to take 1 and we're going to have to add 1.5. And we're just going to keep on doing the same pattern, right? We're going to keep on adding the width of the bar. The width of the bar is delta x, and we're doing that I times. We're doing that over and over. 1 time, 2 times, 3 times, 4 times, and adding that all up. So in our situation, not in this example, but in our situation, our A was 0, because we're going from 0 to 2. So we know that our C sub I will simply be 0 plus delta xi. Well, delta x, I think earlier we said was 2 over n. So I'm going to write it like that. That's an n, not an h, so let's fix that up. And now I'm going to just simply finish and write C sub I over here. C sub I equals 2I over n, and that's in a box. So that's step 4. So now we've gotten through step 1, step 2, step 3, and step 4, and hopefully it's going okay. So now that we have C sub I, the important thing is to remember that that's just an x value. We haven't actually found a y value yet. So what we need to do is we need to figure out the area of each rectangle, right? Well, the area of each rectangle is going to be area equals base times height. Our base is delta x. Our height is not just C sub I, it's f of C sub I. So we have to plug that into the function. So let's take a moment and look at our function. So our function was f of x equals 4x. And our C sub I, which is going to go here, was 2I over n, right? So that's what's going to go there and there. So we're going to have 2I over n. F of C sub I is equal to 8I over n. So that's what f of C sub I equals. That's the actual height of the bars, each bar, and every bar has a different height, and that's where the I comes in. So now we are going to simply write out the area of the rectangle. So we know that the delta x was 2 over n, and we know that the f of C sub I is 8I over n. So that's the area of each rectangle. Area equals base times height. But we want to do this for infinite rectangles. So we want to add up all of these rectangles with I is 1. And how many rectangles do we want to add up? We want to do this infinite times. And so what we're going to do is we're going to take the limit as n goes to infinity. Instead of putting an infinity up there, we're just going to take the limit as n goes to infinity. So we're going to go to n, and then we're going to make n go to infinity. And that's kind of a little sneaky way of getting that done. So this is our setup. So hopefully you had at least some idea of how to set these up before watching this video. That was the hope. And now what I want to show you is the last part, which is the math to finish it out. So let's do the math and actually get an answer now. So what you want to do is you want to look at those problems right there, and you want to take out all of the constants and all of the n's. Treat n's as constants. So n's and constants out. You have to take those out. So first thing I'm going to do is I'm going to pull out 16 over n squared. 16 over n squared is going to come out, and I'm going to leave the limit out front of it. And now it's a summation from I equals 1 to n of, I believe, just simply I. And hopefully you say, I know the summation from I equals 1 to n of I. That's something we've already been doing. So I'm going to scroll down. Hopefully you can scroll back if you need to. And this whole entire thing simply equals n times n plus 1 over 2. That's done. So now we have this 16 over n squared. And we're going to take the limit as n goes to infinity of that. This is going to give us the exact area under the curve, not an approximation, because we're not doing 10 bars or 20 bars anymore. We're not doing trapezoids or anything like that. We're doing an infinite number of rectangles, which gives us the exact area. So we know that the power of the top is 16n squared. That's the highest power. And the power of the bottom is 2n squared. 16 divided by 2 is 8. And that is the answer. The area under the curve is exactly 8. Now what's kind of cool is you can look at this problem for a second. You could say, this was kind of a waste of time in a way, wasn't it? Because we know that it's literally the area under the curve of a triangle, right? So we can say to ourselves, what is the base of this triangle? Area equals 1/2 the base times the height. And that means that our area of this triangle here is 8, right? Now, of course, not all of our figures are going to be triangles. They might be curvy or circle or like wavy. Of course, I use a triangle because it's pretty simple in this situation, so you can kind of see where we got the answer and why it makes sense. Because if you look at that triangle there that's colored in green, and then you look at our original drawing, you say to yourselves, wait a minute, that makes a lot of sense that it would be 8, because that's this area right here from 2, like right here. This is an area of 8, and that's what we were trying to find that whole time. So, of course, that doesn't work when they're curved or anything like that, or increasing and decreasing and weird. So only in this situation, or in some situations, will it come out to a nice number that is way easier by geometry. But of course, you can use geometry to find the area if you like, in addition, to check your work. Okay, so we'll end the video there. Hopefully that made a lot of sense. So I'll see you in the next video. Peace.